The history of artificial intelligence will likely be divided into two distinct eras, before agents and after agents. For nearly a decade, we lived in the era of the chatbot. This was a helpful but fundamentally passive interface. You asked a question, and it gave an answer. If you wanted to book a flight, write code, or analyze a spreadsheet, the AI could tell you how to do it, but you still had to do the heavy lifting. The AI was a brilliant encyclopedia, but it had no hands. In 2024 and 2025, that paradigm shattered. We have entered the era of autonomous agents. These are not systems that just talk, they are systems that do. They possess the ability to perceive their environment, reason about complex goals, break them down into actionable plans, and execute those plans using tools, all with little to no human intervention. To understand where we are going, we must understand what changed. The shift from a large language model, or LLM, to an autonomous agent is a shift from prediction to agency. Traditional LLMs, like GPT-3 or early GPT-4, function as probabilistic engines. They predict the next likely token in a sequence based on vast amounts of training data. When you ask, how do I fix this Python bug? The model draws upon millions of GitHub repositories it has read to generate a solution. However, once it generates the text, its job is done. It does not know if the code actually runs. It cannot see your terminal. It cannot install the library for you. It is an oracle, all-knowing, mostly, but paralyzed. An autonomous agent wraps that brain in a body of capabilities. It gives the model agency. This agency consists of three things: perception, action, and persistence. Perception means it can see your file system, read your emails, or browse the web. Action means it can execute code, call APIs, click buttons on a web page, or send Slack messages. And persistence means it has memory. It remembers what it tried 5 minutes ago, realizes it failed, and tries a different approach. Imagine asking an AI, plan a marketing campaign for our new product launch. A chatbot says, here is a suggested 5-step plan for your launch. An agent, however, actually does the work. It browses your competitors' websites to analyze their pricing. It logs into your CRM to export customer segments. It drafts email copy, creates a temporary campaign in your email marketing tool, sends a test email to itself, verifies the formatting, and then sends you a Slack message saying campaign drafted and ready for your approval. Click here to send. This is not just automation. It is goal-oriented reasoning. The agent is not following a rigid script. It is figuring out the steps as it goes. So what makes an agent tick? If we were to dissect a modern autonomous agent in 2025, we would find 4 critical organs working in harmony. This architecture is often referred to as the cognitive architecture. First, we have the brain. At the center sits the large language model, or increasingly, the large action model, or LAM. This is the reasoning engine. Its job is not just to generate text, but to function as a router or controller. It analyzes the user's high-level goal and decides which tools are needed to achieve it. Its primary role is decision-making, error handling, and intent understanding. Second, we have memory. Humans rely on short-term memory to hold a conversation and long-term memory to learn skills. Agents are now mimicking this structure. Short-term or working memory stores the immediate context of the current task. For example, the agent thinks, I just tried to query the database, but it failed with error 500. I should try again. Long-term or episodic memory is often powered by vector databases like Pinecone or Weaviate. It allows the agent to recall experiences from days or weeks ago. For instance, it might recall, last time the user asked for a weekly report, they preferred the PDF format, not Excel. I will default to PDF this time. The third organ is planning. An agent does not just blindly execute, it plans. Before taking a single step, advanced agents engage in decomposition. They break a vague goal like research the EV market into subtasks. First, search Google for top EV manufacturers in 2025. Second, scrape their latest annual reports. Third, extract revenue figures. Fourth, summarize findings in a table. And fifth, generate a chart. Techniques like chain of thought and tree of thoughts allow agents to explore different possible paths, simulate the outcome of each, and select the most promising one before acting. Finally, the fourth organ is tools. This is the interface with the real world. Tools are defined as functions or APIs that the agent knows how to use. These include search tools like Google Search or Bing API, file tools to read and write files or modify codebases, software tools to interact with Jira, Salesforce, GitHub, Slack, or Gmail, and code execution, which is often a sandboxed Python environment where the agent can write and run code to analyze data or fix bugs. Building an agent is not as simple as giving an LLM access to tools. Developers have discovered that LLMs can be lazy, hallucinate, or get stuck in loops. To solve this, the industry has coalesced around several robust design patterns. These are architectural blueprints for reliable agents. The first is the REACT pattern, which stands for Reason plus Act. This is the grandfather of agentic patterns. Instead of asking the model to solve the problem in one go, the system forces a loop. First, thought. The user wants to know the weather in Tokyo. I need to check the weather API. Second, action. The agent calls the weather API for Tokyo. Third, observation. The API returned 15 degrees Celsius and rainy. Fourth, thought. I have the data, I can now answer the user. Finally, answer. It is currently 15 degrees Celsius and rainy in Tokyo. This explicit separation of thinking and doing reduces hallucinations significantly. The second pattern involves reflection and reflection. Agents, like humans, make mistakes. The reflection pattern involves adding a critic step. The agent writes code, then a critic agent reviews that code, saying something like, "You missed an edge case on line 45. This will crash if the input is 0. The agent then rewrites the code. Reflection takes this further by storing these lessons in long-term memory. If an agent fails a task today, it records why it failed. Next week, when faced with a similar task, it retrieves that memory, thinking, "Wait, I remember failing this last time because I did not check for null values. I will check for them first, this time." The third pattern is tool use, combined with RAG, or Retrieval Augmented Generation. Agents are now standardizing on RAG, not just for knowledge, but for process. An agent facing a complex legal contract might use a legal knowledge tool to retrieve specific case law before drafting a clause. The pattern here is dynamic, meaning the agent decides when it needs external info, rather than having it force-fed. The fourth and perhaps most exciting development in 2025 is the move from single agents to multi-agent systems, or the swarm. Just as you would not ask your CFO to write production code, you should not ask a single generalist agent to do everything. We see the orchestrator pattern, where a manager agent receives the user request and delegates it to specialized worker agents. For building a website, the manager says, "We need to build a website." A coder agent writes the HTML and CSS. A designer agent generates the image assets. And a QA agent tests the code and reports bugs back to the coder. There is also the hierarchical pattern, similar to a corporate ladder, and the joint chat pattern, where agents sit in a virtual chat room and talk to each other to solve a problem. If you want to build an agent today, you are likely using one of the big three frameworks. First is LangGraph, the engineer's choice. Built by the LangChain team, LangGraph treats agent workflows as a graph. Its philosophy is control. It views agents as state machines where you define nodes and edges. It is best for production-grade, highly reliable systems where you need to force specific paths and excels at human-in-the-loop workflows. Second is Crew AI, the manager's choice. Crew AI focuses on role-playing. You define a crew of agents, each with a specific persona, backstory, and goal. Its philosophy is structure, mimicking a human team. You assign a senior researcher and a junior writer and tell them to work together. It is best for creative tasks and straightforward automation. Third is AutoGen, the researcher's choice. Created by Microsoft, AutoGen pioneered the conversational paradigm. Its philosophy is conversation. Agents are just entities that send messages to each other. It is best for coding tasks and complex open-ended problem-solving, where agents need to go back and forth many times. To truly grasp the power of this technology, let us look at two detailed scenarios of agents in action. Scenario A is the autonomous software engineer. At 9 a.m., a human developer assigns a GitHub issue saying, "Fix the slow database query on the checkout page." At 9:01 a.m., the coding agent wakes up. It clones the repository to its sandboxed environment. At 9:02 a.m., it scans the codebase for checkout and database and identifies a specific SQL query in the checkout service file. By 9:05 a.m., it writes a test script to reproduce the slowness, runs the script, and confirms the query takes 2.5 seconds. At 9:10 a.m., it attempts a fix by adding an index to the orders table and modifying the migration file. At 9:12 a.m., it runs the test script again. The query now takes 0.1 seconds. At 9:15 a.m., it runs the full regression test suite to ensure it did not break anything else. Finally, at 9:20 a.m., it pushes the code, opens a pull request, writes a detailed description of the fix, and tags the human developer for review. The ticket is resolved in 20 minutes without human coding. Scenario B is the Tier 2 customer support agent. At 2 p.m., a customer emails saying, "My refund has not arrived, and I was double charged." At 2:01 p.m., the support agent reads the email. It detects high sentiment of anger and identifies the topic as billing. At 2:02 p.m., it uses its Stripe tool to look up the transaction ID. It sees two charges, one successful and one failed or pending. At 2:03 p.m., it reasons that the customer sees the pending charge as a double charge, but knows it will drop off in 24 hours. At 2:04 p.m., it checks the refund status and sees the refund was processed yesterday. At 2:05 p.m., it drafts a reply explaining the pending charge versus the real charge, attaches a PDF receipt of the refund, and offers a $10 coupon for the trouble. But then, at 2:06 p.m., a human-in-the-loop trigger activates. Because the coupon value is greater than $5, it pauses and pings a human manager via Slack, asking, "Approve $10 coupon for angry customer?" At 2:10 p.m., the manager clicks approve. Immediately, the agent sends the email and closes the ticket. Why are businesses rushing to deploy agents? It comes down to the marginal cost of cognitive labor. In the past, high-quality reasoning was expensive because you had to hire a human. Today, the cost of renting a sophisticated brain like GPT-4o or Claude 3.5 Sonnet for a few minutes is fractions of a cent. A complex interaction with a human agent costs between $6 and $12 when factoring in salary, benefits, and training. That same interaction with an AI agent costs between 10 and 50 cents. This 12 to 60 times cost reduction fundamentally changes business models. It means you can offer concierge-level support to every customer, not just VIPs. It means you can have a software engineer agent spend 24 hours straight optimizing a legacy codebase for the cost of a nice lunch. However, a new economic risk emerges: runaway costs. If an agent gets stuck in an infinite loop, repeatedly trying to fix a bug, failing and trying again, it can burn through thousands of dollars in API credits overnight. This has led to the rise of FinOps for AI, where strict budget guardrails are hard-coded into agent frameworks. With great agency comes great risk. Moving from chat to act introduces dangers that never existed with simple chatbots. First is the loop of death. Agents can get obsessive. If an agent is told to maximize profit on a simulated trading desk and it encounters a bug, it might execute thousands of buy and sell orders in seconds, draining an account. Watchdog agents are now required to monitor the primary agents and kill them if they exhibit repetitive behavior. Second is hallucinated actions. A chatbot hallucinating a fact is annoying, but an agent hallucinating an action is dangerous. Imagine you ask an agent to delete all temporary files. The agent might mistakenly identify your operating system files as temporary and delete System 32. To defend against this, agents are now usually deployed in Docker containers or secure sandboxes with limited permissions. Third involves non-human identities and security. Agents need login credentials. They need API keys for Stripe, AWS, and Slack. This has created a massive security blind spot. We have strict protocols for onboarding human employees, but who manages the identity of Agent 007? If a hacker hijacks an agent via prompt injection, tricking the agent into ignoring its instructions, they inherit all the agent's permissions. They can use the agent to exfiltrate data or modify databases, all while looking like valid, authorized traffic. As we look toward the future, specifically 2026 and beyond, the trajectory is clear. 2024 was the year of the prototype. 2025 is the year of production. Companies are moving from cool demos to agents that handle mission-critical workflows in finance, healthcare, and law. We are moving toward ubiquitous digital coworkers. The term user will evolve. You will not just be a user of software, you will be a manager of agents. The skill set of the future knowledge worker will shift from doing the work to orchestrating the agents who do the work. Resume skills will include multi-agent systems management and agentic workflow optimization. We will also see autonomous observability, where agents are designed solely to debug other agents. Doctor agents will monitor the logs of worker agents, diagnosing why they failed, and patching their prompts or code in real time. The transition from passive chatbots to active problem solvers is not just a feature update, it is a fundamental reimagining of our relationship with computers. For 50 years, computers have been tools, hammers we had to swing. Now they are becoming carpenters. They can look at the blueprint, pick up the hammer, and build the house alongside us. The future belongs to those who learn to lead them.